Hello and welcome to this lecture on checked and unchecked exceptions. Compiler can check and force a code to handle any potential exceptions. Exceptions which must be handled by a code are called checked, and compiler actually gives you an error if you don't do that. And the ones that do not need to be handled are called unchecked. However, it's only the compiler that doesn't check. At the runtime, anyway your application is going to collapse. But of course, you have other mechanisms to do also. So at the end of this video, you should be able to understand checked exceptions and you should be able to understand unchecked exceptions. An exception is a runtime error that occurs during execution of an application. So it is not a compiler error and it is not going to be a logical error. We are talking about situations that may arise because of either a wrong input or probably something that involves system connectivity or a file not existing and so on. Now these problems need to be handled. Now an exception may be caused by a runtime interpreting some statements or by a method call. Now as an example, q equals to n by d, assuming n and d are two numbers, especially integers. Now the above statement is interpreted by the runtime. You can see that the slash or divide by operator is going to be an instruction to the runtime, and at that point in time if d happens to be 0, then runtime has a problem because runtime cannot divide an integer by 0. So runtime will now create a problem, and that problem is an exception. Now here is another statement. In equals to new file input stream some file.txt. Now we are basically creating an object of some class called file input stream. It's a constructor call and it's some mechanism. Obviously file input stream is a class developed by some developer. Now there the developer would go and check for the file that you are given. Now if the file that you are given is invalid, now how can they open that file? Now that is a problem too. Now that situation is now being determined by the developer, and the developer would have added that if condition saying that if this file doesn't exist, let's throw an error, and that error comes in the form of an exception. So that is something that we need to take care of too. In both the cases, if the exception is not handled by the code, the runtime would just stop the execution of the program abruptly. Now that's a very bad thing as a user of the program, because you don't want the application to collapse, not even for any reason. Even though both the statements would stop the execution of the program, the compiler treats these two statements differently. Now why is that discrimination? For q is equal to n by d, compiler has no problem. It allows you to run the code, but only at the runtime if d happens to be 0, you get an error. But compiler passes this statement. Now for in equals to new file input stream, the compiler now tells, hey, there is a potential problem here. You should surround this with try catch or handle this in a different way. Now both the cases there is a possibility of runtime, but why compiler told only for this? Now let's look at what is unchecked exceptions to understand this. Unchecked exceptions are all exception classes that inherit from java.lang.runtime. Now there are many of them, and even you can write your own. Runtime exception inherit from exception, which inherit from throwable, and that inherit from java.lang.object. Now all the classes that inherit from runtime exceptions, such as null pointer exception, index out of bounds exception, number format exception, all these are easily being passed by the compiler, which means if you find a statement that actually throws one of these, compiler has no problem. It is problem at the runtime though. Unchecked exceptions are often thrown while runtime is evaluating some operators, but most of the time, but not necessarily. For example, a divided by b might probably throw an arithmetic exception because that involves some arithmetic operation. B divided by 0, a divided by 0 may be a problem, so that needs to be taken care of. Now a of n, or you're accessing an array element with an index n. What if you have supplied an index that is beyond the length of that particular array? You get an array index out of bounds exception. Note how the naming convention is followed. The name itself pretty much tells what actually is the cause of the error. A equals to new int of -4. Now array index always start from 0. The array length also is like 0 is the minimum. If you give a negative number, how can you even picturize an array with a negative size? Now Java compilers actually would have checked and put some code, but at the runtime you're going to get an exception called negative array size exception. There is a.f. What if a is a reference to an object, but at this point in time a is not pointing anywhere? So a is null, so null.anything is a cause for null pointer exception. So literally every function call you make is a potential problem. So this is the reason why Java compiler is not going to force exception handling on you. Otherwise, for every statement you have to put some exception handling mechanism. But you can also get these unchecked exceptions from some API functions. Now, not necessarily API functions alone, but I'm just showing you some of the API functions. Java.lang.number format exception is thrown whenever you're trying to convert a string into either an integer or a double. Now, what if I say ABC and give me a number version of this? Now, the parseInt function would not know how to do that. It would throw an exception. However, if I give a string containing only digits, integer.parseInt has no problem. So also double.parseDouble. Java.lang.index out of bounds exception is thrown when you are trying to access an element from or a character from a string with a wrong index. For example, the possible index values for Vinod is 0 to 4 and I supplied 10 here, and this is going to give me an error. Index out of bounds exception. You should probably check what is the length of the string and then actually access its elements. Illegal format exception, one more from java.util package. This is thrown when you are trying to supply some string and say print it using a printf function, and that does not have a format specifier or a wrong format specifier or not enough values for the format specifier. You get this illegal format exception. So these are all unchecked exceptions too. Now let's look at checked exceptions. Checked exceptions are objects of throwable classes and its subclasses, excluding the runtime exceptions. So here is a picture that might tell you in a better way. Now as you can see, if you exclude the runtime exception and its subclasses, the rest all are checked exception. So whether an error was thrown, whether a throwable was thrown, exception was thrown, IO exception was thrown, your compiler is going to force you to put a try-catch block. Now that something is a reason why it is called as a checked exception. The compiler checks if a statement that is possibly a potential cause of an exception, it has to be protected by an exception handling mechanism. Now compiler is now going to see, have you done this using a try-catch block, or have you specified throws class of the method that you are writing? Now if none of these are done, compiler would now give an error, and obviously without compilation you can't run the code. Let's take an example. Java.io.star has been imported, which means I'm going to use all the java.io APIs here, and in the class A I have a function, and I have here input stream in as a semicolon, so as a statement variable here. Now I have this variable, that is not a problem, but I am assigning an object. Now assigning an object is done using file input stream object. At this point in time, now if you try to compile, compiler will now look into each of these lines of your code. For example, inside the void f function, the first statement is not a statement, it's just a declaration, but the second line in that particular function is a statement. Compiler sees, is this a potential for checked exception? And the answer is yes. And now compiler will result in an error. It says unreported exception, file not found exception must be caught or declared to be thrown. Now note that there are two choices. Either you need to catch this or you need to throw it away. Let's see both of them. Now in the statement in equals to new file input stream, the constructor file input stream has this particular prototype. Public file input stream string name, but also has throws java.io.file not found exception. Now when compiler comes across the statement in equals to new file input stream, it would have checked this signature and says that, hey, this constructor is probably going to throw you an exception, which is a checked exception. But I have not handled it. Since java.io.filenotfoundException does not inherit from java.lang.runtime exception, now call to this constructor must be protected either using a try-catch block or you should further throw it away. So there are two solutions to this. Number one is to handle it. Let's look at a class A redefined. Now I have a method f which takes an input string name, the file name, and now we want to open this. I create a variable in of input stream type. Now I need to initialize that with an object. So in equals to new file input stream. We saw this earlier. But however, this time I'm going to put a try block. So I would like to try opening this file. Now if it fails because the file doesn't exist, now file input stream would have thrown an exception, and the thrown exception is going to be received by my catch block. Now of course the catch block here is empty, but you're going to do some kind of handling on that. Now the solution number two is where I am not interested in handling because I would just like to report this to somebody who called my function. So class A defines method f. The same thing, we declare an input stream in. We are trying to call this function constructor and then we are trying to initialize the object. We're going to work with the file, but only if this constructor throws an exception. I'm not interested to handle it. I would further throw it away from my function, which means now I am declaring my function as to throw file not found exception. So whoever is calling my function, now they are supposed to handle it with a try catch block. Call to the method f of the class A is a good candidate for throwing file not found exception. It is just like the constructor we used, so someone else who is using my function f need to protect their code. So call to this method must be protected in a try catch, or they should further throw it away from this. For example, if they are calling this from a main function, now it has to be thrown away from the main, and the main function was called by the Java runtime. Java runtime would handle that. Now, when Java runtime is calling your function, your main function, Java runtime would have put it in a try-catch block, receiving any kind of throwable objects. Now, hence, now that handles that and simply prints all the methods that were involved in this particular exception and then stops the execution of the program. Now, that's something is up to you. Do you want to do that, or would you like to handle it and report to the user that there was something wrong? Now, generally, you need to handle the exception rather than just throwing it away. So solution number one, class B, where I have a main function, I'm going to put a try block while I'm calling this particular function f so that it is protected. Now f is a candidate for a file not found exception, so it is better to handle that in the try catch block, so I handle this. This is the solution one. What is solution two? Now solution two is where I have class B, where I'm trying to have a main function. I'm trying to create an object of A and call the f method, but that is a candidate for file not found exception. If you don't handle that, then compiler is going to give an error. Now this time the way we want to handle it is, we would like to say main function throws file not found exception. Now since main is going to be called from the Java runtime environment, that is going to handle that and stops the execution of the program. Now let's look at custom exceptions. You may create a custom exception class by extending an appropriate exception class. For example, I can have invalid salary exception as a subtype of throwable. Now that's one choice that I have. This becomes a checked exceptions. I can also do the same thing by extending an exception. Now this is also going to be a checked exception. However, we can have an invalid salary exception extending runtime exception, which means whenever I throw this, now nobody needs to handle this, but of course at the end of the day, the program is going to collapse. Now given these three choices, now throwable is generally not going to be used for throwing by application developers. Frameworks and Java runtime environments will catch any throwable objects. That might even include errors. Now, if you write a class that is inheriting from exception, this is a good practice to do as an application developer. However, if you are a framework developer, then it's a good idea to take all the exceptions that you got and convert and throw it in the form of a runtime exception. So for framework developers, we would suggest that they go for a runtime exceptions. Let's quickly summarize what we have done. Unchecked exception classes inherit from java.lang.runtime exception. Any other exception classes, including throwable or exceptions, or even for that matter errors, they're all considered as checked exceptions. When a method intends to throw a checked exception, it can be described in the method prototype using throws keyword. Now the throws keyword can also be used with an unchecked exception, but generally people don't do that, but it's a good practice to do.